All right, ladies and gentlemen, set 54 is on rectangular coordinates and polar coordinates. Rectangular coordinates is it's like our typical x, y coordinate that we've done before. The only thing is we omit the parentheses, and now we're going to use plus r for right and minus r for left, and plus u for up and minus u for down. Otherwise, it's pretty similar, not too difficult. So let's take a look here. If I have 4r plus 5u, that means I'm going to go 4 to the right. So 1, 2, 3, 4 to the right, and up 5. 1, 2, 3, 4, 5. So that is my new coordinate. That's my 4r. Oops, sorry, parentheses, bad habit. Not a bad habit, good habit. 4r plus 5u. All right, let's look at our next one. Negative 2r, so I'm going to go to the left 2 and up 7. So negative 2r plus 7u. See how it's not that bad? Okay, 5r, so I'm going to go to the right 5. And some you might see it say plus 5r. Some you might just see 5r. So I go to the right 5 and minus 2. So I have 5r minus 2u. And negative 3, negative 3r, negative 1u. So go to the left 3, down 1, negative 3r minus 1u. So rectangular coordinates are just like our standard Cartesian coordinate that we do right now. Then we have polar coordinates. Polar coordinates are based on location of a point, and we talk about it by angle and distance of that point from the origin, and we talk counterclockwise. So here, if I have my xy, and I have 6 as my length, and 86 degrees. So remember, here's 90 degrees. This is going to be 180 degrees, 270 degrees, and this is over here is going to be 0 or 360 degrees. Okay, so 86 is going to fall in my quadrant 1, and I'm going to be almost at 90, and I'm going to be a length of 6. And then we just represent there. So my distance here is my 86 degrees. So that makes my new point here. Polar coordinates are also called vectors, and that's talking about magnitude and direction. And that is used in like airplanes or boats. They use vectors and they talk about the angle and their direction from a certain point, and that gives their new position. So let's look here. We did our 686, and now in my plane, when I draw my 6 length, I'm just going to draw a line. It's not going to measure to 6 on the plane because remember it's at an angle. Okay, so let's just call that. There's my 6. So this is my 686 degrees. All right, my next one is 3, and it's in the direction of 320 degrees. Let me put this up here again. 90, 180, 270, and then 0/360. Okay, so this one's at 320, so it's going to fall in my quadrant 4, which is going to be between 270 and 360, and it's going to be closer to the 360. And it's going to start at my origin. It's going to go out. I'm just going to draw a distance of 3. Okay, I'll color green here so you know it's that one. 9 and then 196. 196 is going to fall below my 180, but not quite to my 270. So here's my origin. It's going to have a length of 9, so I'm just going to draw it longer. Okay, and my last one is going to be 154. That's going to fall in quadrant 2 between 90 and 180. It's going to be a little bit closer to the 180, kind of in the middle. Okay, and it's got a distance of 4. And notice my lines have absolutely no length and rhyme and reason to their length. I just drew some. You're not going to be asked to just draw them like that. Actually, what you're going to be asked to do is converting them. And we're going to use trig to help us to convert between rectangular and polar coordinates. So let's go back to that original thought process here. If we have our axes, this original problem was 86 degrees for this and had a length of 6. So what we're going to be using is we're going to use trigs. So that means we have to have right triangles. So it means we bring down and bring down. This is going to help us find our rectangular coordinates. How much do I go to the right? How much do I go up, etc. So let's redraw my triangle here. Here is the spot. It's a length of 6 and a degree of 86. Okay, so I'm just going to use R and U representing my lengths. R tells me how much I'm going to the right or left. U tells me how many I'm going up or down. Okay, let's find U first. So that is going to be my opposite. 6 is my hypotenuse, and R is my adjacent. Okay, so we see here to find my U, it's going to be the sine, because that's opposite over hypotenuse, of 86 equals U over 6. Okay, to find U, I take 6 times the sine of 86. And I'm going to do that on my calculator here. Make sure your calculator is in degrees, not in radians. So that tells me U, and I'm going to round to 2 decimal places. Oh, 2 decimal places here. This one is 5.985. So I can leave it like that, or I could round it to 6.0. Okay. Now let's go ahead and calculate it here for R. And my R is my adjacent, and I'm going to use my hypotenuse. So that means I'm going to use cosine of 86 equals R over my hypotenuse. So R equals 6 times the cosine of 86. You guys are going to get really good at these trig functions. I'm going to type that in my calculator. So R equals 0.42. I'm rounding to 2 decimal places. So I have my U and I have my R. And I'm going to write that. I have to write it in rectangular form. Remember, R comes first. So 0.42 R and plus, we can say 0.60 U. Both of these are positive because I know I'm going to the right and I'm going up. Okay, so here would be my rectangular coordinate. Let's try it again. Rewatch this one if you need to. Let's look at this one. If I have my drawing here, now I'm starting here and I'm going around to 320. So this huge angle here is my 320. And then my length is 3. Now I have 2 triangles I could draw here. And I could draw the one up and here. And I prefer that one. But some people will prefer to use this one. That's fine also. The thing is, we have to decide what angle we're going to use. 320, if I go and use my green one, I'm looking for this angle in here, which isn't 320, it's actually 40, because it's my distance from 360 down to my 320. So I have 40 and a length of 3. Here's my R, here's my U. I'm going to do it out this way, and we can talk in class tomorrow about using the blue triangle. Okay? All right. So my U is going to be my opposite this time, and my R is going to be my adjacent. R and U, R is not always adjacent. Sometimes it could be opposite. So don't say, oh, every time R is adjacent. Doesn't always happen that way. Okay, so if I want to find my U, I'm going to use my sine of 40 equals my opposite over my hypotenuse. So U is 3 times the sine of 40. Type that into your calculator, and we find U, if we round it to 2 decimal places, is 1.93. Okay, there's half of it. Now let's go ahead and find our R. R is going to use cosine in this problem. Is going to be adjacent over hypotenuse. So R equals 3 times the cosine of 40. Type that in. 3 times cosine of 40. 2 decimal places, it's, let's see here, R equals, it's 2.298. So the 8 tells the 9 to round up. So that's going to round to 2.30. Okay, but we can't just leave our answer that way. We have to put it into our rectangular form. Ooh, now I wrote that as a positive, which is good because R is positive, but notice U, this time we're going down. Um, so we actually need to write minus 1.93 U to represent the fact that it's going down. Now, you have to be careful of that and keep your eyes open for that. Okay, we'll do some more of these in class. I know that these are going to be a little bit more tricky for some students, and that's totally okay. So we'll be practicing these more and more. See you guys later.